Now basic dimensioning: extension line, dimension line, leader lines, dimension numbers, local nodes. That is we have already discussed briefly. Now I will discuss quickly. First of all, extension line. Here the lines you extend for writing of dimension, this is called extension line. Now dimension lines, here these are dimension lines. Now leader line, when the writing of radius of or circle, we point the arrow and take it outward of the shape and write the dia or radius of the circle. So this is called leader lines. Again, the radius of this arc, this is leader line. Dimension numbers, we write the dimensions numbers, 10 millimeter, 27, whatsoever. So these are called dimension numbers. We often write local nodes. In the local nodes, we mostly mention the description of the object, like what is the material, either it is a steel, wooden, or some brass material. In the local nodes we write, or write some precautions, so that is written in the local nodes. That is again the local node, 10 drill dia in the world, radius 16. So these are numbers. These are also local node. Tangencies and intersections, that is also a students face confusion. So here I will try to cover tangent and intersection. No line is formed when curved surface tangent to a plane surface. Here when you see from this side, from the front, you will see the curve, and when you will see from the top, you will see this edge. You will not see the joining of this, because that is a smooth transition. So here when you will see from this side and when you will see from the top side, that is a tangent, no line will form. Okay, no line will form here. So here when the line will form, when two surfaces will intersect. Here one surface and second surface are intersecting at this point. At this point, when we will draw the top view and the right side view, we will need to draw the solid line here and here. So that is the difference between tangent and intersection. At the tangent we do not draw the line, at the intersection we draw the line. There is another example. Okay, here is tangent. Okay, at this point there is a one surface, another surface are meeting, so there will be drawn a line, and when you will see from the top, there will be no line. Tangent, intersection, so that will be here in the right side view, not in the top view. Here again, so here you will see there is a new thing. Here is a tangent, but when you will see, there is a cut also. So here there is a plane, so that will be drawn. So when you will see from the top, just like a limiting line. Okay, so this there will be also a line will be drawn. Now there is some quick examples and practice of tangent and intersection. Here is a top view. When you will see from the front face, this line will be drawn as a solid line because two surfaces are intersecting here. Now by using meter line, this is top view, this is front view, right side view, solid object. Okay, you get this object. Now for this object, okay, here that is a in this object, that is not a separate, basically that is a tangent, is smoothly joining the circle, so there will be no line. Use meter line for right side view. Meter line is a option. you can avoid the middle line, you can directly draw this object. Now again tangent. Okay, for the circle, center line is drawn. Now here is also tangent, here is also tangent. Line will not be drawn. Just why here we drawn? Because two surfaces are meeting and intersecting. Here that is smoothly due to tangency entering to the other body, so that's why not drawn. Okay, and here also dotted line is shown because the cut is extended to the center line, so that's why dash line is shown. So that's the new thing, tangent and intersection. Now there is a small quiz. You have to imagine while watching this lecture. So here, now which should be natural position of the light? A, B, C, D. You have 20 seconds. When you will place the bulb, so at any place, so what will be its natural position? Here, so that was its natural position. So which are the necessary views? So for drawing this object, either this view will be enough. When you will see top and side will be enough, you need a right side view. How much views will be needed for this object? You have 60 seconds, then the answer will appear. Okay, so why? When you will see from this side, you will get the idea of this hole, and what will be the when you will see from the top, so you will get the thicknesses, location of holes. So these triangles will be enough, A and E, top view and the front view. So that's all for today's lecture. Have a nice day.